deflection equation and the slope equation for a cantilever beam with a uniformly distributed load. First thing first, before I can derive the deflection or the slope equation of a cantilever beam with a uniformly distributed load, my first task is to draw a diagram illustrating cantilever with a uniformly distributed load on it. Alright, as you can see, cantilever with uniformly distributed load, UDL, uniformly distributed load. So we're going to be deriving this slope equation and deflection equation by using double integration method. My first task, first and first, I need to draw out a cantilever beam with a uniformly distributed load. So by illustration, I have this to be my cantilever beam this way. Alright, with a what? A uniformly distributed load is illustrated in this format, as you can see in front of you, right? So having considered this, right, having drawn the diagram, the next task is to put an indication of weight, W kilonewton per meter, right? So I have this to be my cantilever beam with a uniformly distributed load. Now my next task here now, listen, my next task is to section this. If I section this way, long one, short one, long one, short one. If I section this this way, let me call the distance from this point here to this point, let me call it x. From this point to this point, let me call it x. And by mathematical approach, if I call from this point to this point, if I call it x, the half will become what? X over 2, x over 2. Half the distance, half the distance. So it simply means that x over 2, okay. Since I've explained the concept here, it simply means that the center here, half of it is what? X over 2, x over 2, right? Alright, my next task now is that call this point here, call this point x, call that point x. Now before I can proceed, let me recall you on how to convert uniformly distributed load to a point load. For instance, if I have a beam this way with a uniformly distributed load of, let's say, 5 kilonewton per meter, and the distance is given to be 10 meter. I want to convert this uniform distributed load to point load. What do I do? Simply take this value. That is what? 5 kilonewton per meter. Sorry. You see the same thing? Per meter. Multiplied by the distance times 10 meter. Meter cancel out meter. I'm left with what? 10 times 5. That's 50 kilonewton. It simply means that if I redraw the diagram, I'll be having something like this. It will act. That's what? 50 kilonewton. Year to year is given to be 10. Now, listen. I have converted this uniform distributed load to what? Point load at this point. Now, observe something. Whenever you convert uniformly distributed load to point load, it always acts at the center of that beam. Now, when I redraw this, you see it acts at the center. That is, center from here is 5. Yes, since here is 10, automatically here is 5, here is 5, because it's acting at the what? Center. So whenever you convert uniformly distributed load, it acts at the center of that beam. Alright, let's proceed. Having understand this concept, let's get to the derivation of the slope equation before the deflection. Alright, now I need to convert this unit. Now listen, I'm going to ignore this part, concentrating on this part. Now I want to convert this uniform distributed load to point load. What do I do? The way we did it here. Take this value, I have W kilonewton per meter, right? Multiply it by what? The distance here is because it's a meter. So meter cancel out meter. If I multiply, I have Ws kilonewton to be the what? To be the force, right? The force acting at the what? Center of the beam. So therefore my force what? Ws kilonewton. We act at the center. Let me just draw this for you. So Wx is acting at the center. Now let's take a look at this point. Moment at this point. If I take a look at this point, it simply means that mx, moment at point x, is equal to. Now, if I take a moment at this point, it simply means that they are fighting at this point here. This point load that I've converted Wx, if it wants to come to this point, it will move what? In a what? And in a clockwise direction. Clockwise direction. That becomes what? Wx, we said moment is simply what? Force times perpendicular distance. So the force here is what? Wx. Multiply by distance from this point to this point is what? Multiply by what? X over 2, not x. Distance from this point here to this point, from here to here, is given to be what? X over 2, as we illustrated earlier. Right? So, I'm done with that. Next up, my mx is equal in value to ws times x over 2. That becomes wx squared over 2. Here is my mx for a cantilever beam with uniformly distributed load. Alright, my next task now, listen please. My next task now, after I've got my mx, right? After getting my mx, I'll recall something. Recall something, please. Recall that mx, whenever you see mx, is always equal in value to ei d square y over dx squared. Whenever you see mx, it's equal in value to ei d square y over dx squared. So instead of me writing mx, I will write this value here. Because if I'm saying something is equal to something, it simply means that all this value can represent mx. Also, mx can represent what? All this value. So I want to ignore mx now. Replace it with this value. That becomes mx, I'll write this value. That becomes ei d square y over dx squared, right? Ei, this mx is all this, is equal to wx squared over 2, right? At this point, my first task now at this point is to bring out d and the x. That becomes ei, bring out from this, all this, bring out d and what? And the x. I'll be left with what? Dy over dx. If I multiply the d and dy, I'll have this. If I multiply this and this, I'll have this. That's the idea. It's equal to wx squared over 2. At this point, take the x to multiply all this. That becomes ei d over, ei d. We are taking the x to multiply all this into dy over dx is equal to dx. This dx is here into wx squared over 2. I have this. Next up, my next task here is to multiply this with this. That becomes ei d into dy over dx. That is all what is here. It's repeated down here. Is equal in value to wx squared dx over 2. I have this. My next task now is to take the, listen, my first task, I take the x, multiply this. I have this. Now take d to the other side. Whenever d crosses the equality sign, becomes integration. That is the key word. That becomes ei into the y over the x is now equal in value to, I said take d to the other side, that becomes what? Integration. Integral what? Wx squared dx over 2. I have this man. I have this. Next up, if I proceed, now listen, from the previous video, when we derived simply supported beam with a uniform distributed load, when we derive the slope and the deflection, I explained the concept of integration. So if you don't know how to derive the slope and deflection of a simply supported beam with uniform distributed load, kindly kindly check the description of this video to watch that video. Alright, at this point, that becomes EI into the y over the x is equal in value to, now I'm having integration sign. My first approach is to bring out the constant term. W and 2 are constant term, bring them out. W over 2 integral the remaining one x squared dx. Bring out constant term, replace your integral back and write out the value back. I have this. At this point, that becomes EI into the y over the x is equal in value to W over 2. We said for integration, simply add 1 to the power, that's all. For integration, add 1 to the power. Now, and listen, here's one trick you need to know. If I integrate the x, I will have x. Note that. If I integrate the y, I will have y. Now listen, here's the idea, please. Wx, if I integrate x squared, we said add 1 to the power. That becomes what? Into x to the power of what? 3. Because here is 2. If I add 1, becomes what? 3. Over this 3, put it down. That is the idea of integration. Alright, close it up. I said if I integrate the x, that becomes what? Just put plus c. I have integrated all this value here. Now add plus c because of this the x. Now at this point, if I proceed, if I simplify, I'll be having my first equation at this point. If I proceed, I'll be having EI into the y over the x is equal in value to W times x squared becomes WS cubed, rather S cubed. 2 times 2 becomes 6 over 6 plus c, right? Plus c. At this point, call this equation 1. Call this equation 1. Here's my first equation. Here is my first equation. Next up, from this equation 1, let's proceed. If I proceed, here's the idea. From our first derivative, we said bring out d and the x. Now, alright, at this point too, bring out d and the x. That becomes EI, bring out d and bring out the x. I'm left with only y. Y, d times y becomes the y. There's an invisible one down here. Dx times 1 becomes dx. So therefore, I'm left with what? Only y is equal to Ws cubed over 6 plus c. Right? Plus c. Now my next step is that if I proceed, I'll take the x to the other side as we did initially. That becomes EI d into y is equal to, we said dx to the other side, multiply everything with the x. Ws cubed over 6 plus c. I have this. If I proceed mathematically, I'll be having EI d into y is equal in value to the x times all this. That becomes Ws cubed dx over 6 plus c times dx becomes c dx. that becomes EI into y is equal to, d comes and becomes integral ws cubed dx over 6 plus integral c dx. At this point, we said for integration, bring out the constant term. That's the first approach. That becomes EI into y is equal in value to w over 6 is my constant term. Then integral x cubed dx. I'm done with this. Plus c is my constant term here. Integral what? Dx. I have that. Now at this point, if I proceed, I'll be having EI into y is now equal to w over 6 into, if I differentiate x cubed, that becomes x to the power 4 over 4. We said add 1 to the power, and when I add the power, put it as what? As the denominator. I have this. Plus, this is c into, we said if I integrate the x, initially when I showed you, if I integrate the x, I have what? X. That becomes x. Now, this becomes what? Plus d. Add plus d to it. Add plus d to it. Now, at this point, if I simplify, I will get my equation 2 at this point. So if I proceed mathematically, right, I'll be having my second equation to be EI into y. I have EI into y is now equal in value to w times s power 4 becomes ws to power 4 over 6 times 4, that becomes 24, plus, this is a positive sign, plus, this is c times x, that becomes cx plus d. Call this my second equation. This is my first equation, second equation. At this point, we are almost through we're almost through. Alright, we're almost through. At this point now, after getting the first equation and the second equation, my next task now, listen. We said mx is equal to EI the square y over the x squared. We replace our mx with what? EI the square y over the x squared. Having done that, we input, we pick out d and the x, right? We multiply all the left hand side value with the x. Then we take d to the other side, it becomes integration. Having done that, we got equation 1. Also, we apply that concept, we got equation 2. Now, after getting equation 1 and equation 2, pick out equation 1. Now, from equation 1, from equation 1, make the y over the x, make what? The y over the x to be 0 and what? X to be what? N. Anywhere I see the y over the x, I will put that 0. Anywhere I see x with what? N. To what? Get my slope. Yes, for me to get my slope. Now that becomes what? EI in my first equation, the y over the x is equal to ws cubed over 6 plus c. We said anywhere you see the y over the x, put 0. Anywhere you see x, put n. That becomes EI into 0. Why? Because the y over the x what is 0 here is equal to wx is what? L. That becomes L to the power 3 over 6 plus c. Now at this point, this becomes 0. That becomes what? 0 is equal in value to wl cubed over 6 plus c. Take this c to the other side. That becomes minus c is equal to wl cubed over 6. And my slope is c. And I can express slope in negative. Put negative sign to the other side. That becomes c is not equal to minus wl cubed over gotten C. Now listen, when we got equation 1, equation 2, we now say pick out equation 1. Make the y over the x 0, x to the n. If you do that, you will get C. Also, pick out equation 2 as we did for equation 1. Pick out equation 2. If I pick out my equation 2, I'll be having, I will get D, right? Pick out your equation 2. What do I get? If I pick out my equation 2, which is what? From equation 2, right? Make what? Y to be 0, then x to be what? N also. Make y to be 0, x to be what? N. That's all. That becomes what? My equation 2 is what? I into y is equal in value to w x to the power 4 over 24 plus cx plus d. This is my equation 2. That is to say, anywhere I see y, I'll put 0. Anywhere I see x, I'll put n. That's all. That becomes ei into 0 is equal to w x is what? N. X to the power 4 over 24 plus c x is what? N. Sorry, x becomes n. That is n. Yes, n plus d. I have this. Next up, I need to take d to the other side. That becomes what? This becomes 0 is equal to w x to the power 4 over 24, right? Plus cn, because we said this is cx. X is n. So plus d. Take this to the other side. That becomes minus d is equal in value to w x to the power 4 over 24 plus cn. That's all. Now, I need to get D, right? So, but you can see this is C. But we already know the value of C to be this, right? We know the value of what? C to be this. So if I put C inside this stuff, I will have minus D is equal to W x to the power 4 over 24 plus C is what? Minus. So clean out this positive sign. Because minus what? W x to the power 3 over 6. Note that there's N here into N, right? I have this. If I proceed, I will have minus D is equal in value to Wn over 4 to the power 4 over 24 minus Wn to the power 4 over 6. Why? N to the power 3 times N, N to the power 4. That's it. Now my next task is what? Get LCM. If I get LCM, my LCM here what? 24. Alright, minus D is my first task. Minus D is equal in value to instead of this, my LCM here will what? 24. LCM will what? 24. 24 in 24 is 1. Multiply by W to the power 4, I have W to the power 4. Now, alright, 24 is 6. That becomes 4. Right? 24 is 6. That becomes 4. Right? 4 multiplied by W to the power 4. That becomes minus 4 into W to the power 4. I have this. Next task, minus D is equal to, listen, that becomes minus x to the power 4 minus 4 W to the power 4 over 24. If I proceed, I will have minus D to be equal in value to W to the power 4 minus 4 W, and that becomes what? Minus 3 W to the power 4 over 24. At this point, if I proceed, I'll be having minus D is equal to 3 here 1, 3 here, that's what? 8. That becomes W to the power 4 over 8. Now, after you have gotten D and C, now pick out only equation 2 now. Pick out only equation 2 and put these two stuff inside. That's all. And we get our deflection. So note something, please. This is my equation 2 here, right? We said pick out equation 2. This is my equation 2. Instead of me repeating equation 2, instead of cleaning it. So I know very well that this is my equation 2. Pick out what? Equation 2. This is my equation 2. Let me clean all this. Avoid confusion. So pick out equation 2. This is my equation 2. Of course. Now, pick out equation 2. So let's put C is equal to minus W x to the power 3 over 6 and D is equal to W x to the power 4 over 8. Anywhere I see D, I'll put this stuff. Anywhere I see C, I'll put this stuff to get my what? Deflection. Y. That becomes EI into Y is equal in value to Wx to the power 4 over 24 plus C is what? Minus, ignore this sign, minus what? Wx to the power 3 over 6. X, there's an X attached to it. Put your X back. Right? Plus D. D is what? Wx to the power 4 over 8. Now, after you have put your substitute C and D into equation 2, the deflection Y is maximum when x is equal to 0. The deflection Y is maximum when x is equal to 0. At that point, whenever I see x, I'll put 0. That becomes EI into Y is equal to W into 0 to the power 4 over 24 minus W x to the power 3 into 0 to the power over what? 6 plus W to the power 4 8 this way. Now this is 0, 0, it's off. I'm left with what? EI into Y is equal to W x to the power 4 W x to the power 4 over what? 8. Now if I multiply, if I take EI at this place, my deflection Y will be equal in value to my deflection Y. If I take EI at this place, that becomes Y is now equal in value to W x to the power 4 over 8 EI. Here is my deflection equation for a cantilever beam with uniformly distributed load using double integration method. Now, there are two things you need to know under this concept. What are the two things? You must know the deflection equation and slope equation. For my deflection equation, it's going to be this. While my slope equation, as we did initially, was minus W x to the power 3 over 6 EI. Note these two stuff are very serious. Note these two. They are very basic things to know under this concept. Under cantilever beam with uniformly distributed load using double integration method. Alright, let's take an example under this and let's end this concept. Example 1, under cantilever beam with uniformly distributed load using double integration method. An example under that. A cantilever projecting 2.5 meter from a wall. My first task, listen, is to read out this question and interpret this question in form of diagram. Now, a cantilever projecting 2.5 meter from a wall is loaded with a uniformly distributed load of 8,000 kg. Determine the moment of inertia of the beam section if the deflection of the beam at the free end is 1 centimeter. Take E. E is what? Young's modulus. Young's modulus to be what? 2.05 × 10⁶ kg per centimeter. My first task here is to what? Redraw this interpret this in form of diagram. We said a cantilever beam. This is a cantilever from here to here is simply what? 2.5 meter, the distance, right? Alright, they said with a what? Uniformly distributed load, right? Look at this point, with uniformly distributed load this way, right? With a uniformly distributed load, as I have done this way, of what? 80 kilogram. 80 what? 80 kilogram. 80 kilogram. Of 80 kilogram. So of 80 kilogram, 8,000 kilogram, right? Of 8,000 kilogram. Now determine the moment of inertia of the beam section. If the deflection of the beam at the free end is 1 centimeter, take E. Now after I've drawn this, right? After I've drawn this, my first task now is to draw the deflection of this stuff. The deflection will be something like this. Since it's a uniform distributed load, my deflection will come this way, right? Come this way. So what is here is y. So my y is going to be what? My deflection y is going to be what? 1 centimeter. Now listen as parameter. I'm giving what, please? I'm giving number 1, my length, the length of the cantilever L to be 2.5 meter. Next up, I'm giving the weight W to be what? 8,000 kilogram. Next up, I'm not given I. I'm going to look for determine the what? Moment of inertia, which is I, is equal to, I don't know. If the deflection, I'm giving deflection y to be what? 1 centimeter. And I'm going to take Young's modulus E to be 2.05 times 10 to the power 6 kilogram per centimeter. Now, my first task, before I start solving question, am I converting? I'm seeing centimeter, kilogram, centimeter, I'm good with that. Kilogram, I'm good with that. Meter, I need to convert this to what? Centimeter. That becomes, if I convert to centimeter, that becomes 250 centimeter. Now, I can now recall formula. Now, from our idea of cantilever beam with an uniform distributed load, our deflection y, if we recall, our y is equal to what? WL to the power 4 over 8 EI. WL to the power 4 over 8 EI is 4 over 8 EI. So I need to input parameter. Now, note something in the question. They say determine the what? Moment of inertia. We are looking for I, and this is our I. We are given Y, we are given W, we are given L, we are given E. Now look for I. 8 is constant, so we can do that by what? Apply the concept of change of formula to get our I. So if I input value, right? So what do I get? That becomes, if I multiply, I will have 8y EI is equal to WX power 4. Divide through by 8ye. That becomes divide through by what? 8ye. That becomes 8y EI divided by what? 8ye is equal to WX power 4 over what? 8 y This cancel out this. I'm left with I. My I now will be equal to WX power 4 over 8ye. Now my I is moment of inertia is equal to W, please, is what? W is 8,000. 8,000 multiplied by my L. Length is what? 250. 250 to the power of what? 4 over 8 multiplied by Y is 1 multiplied by E is what? My E, don't lose, is what? 2 At this point, if I punch my calculator at this point, I'll be having the answer. So my I is equal to, if I punch 250 to the power of 4 multiplied by 8,000, right? I'll have multiplied by 8,000. I have 3.125 times 10 to the power 13 divided by, if I punch this stuff, that becomes 2.05 times 10 to the power 6 multiplied by 8. I have that becomes 16 million 400 16,400,000. I have this. So if I divide my numerator 3.125 times 10 to the power 13 divided by divided by 1616400,000, I will have 1 point I is now equal to, my I is equal to 3.125 times 10 to the power 13 divided by 164,123. I have 1905487.8 centimeters per 4. Here is my answer to that question. If you found this class helpful, kindly click on the subscribe button and like. Thank you. Also share to your classmates and friends. Welcome to Excellence Link Academy. If you have any question, you can simply ask your question in the comments below. Thanks for watching.